So now we'll discuss some important results which we obtain from this straight lines. Okay. So first of all, we'll discuss if we have two straight lines. Let's say these are two straight lines. What is the angle between these two straight lines? So first motive is that. Okay. So how are we going to find these angles? Let's say this line is L, this line is M. So first of all, we need to understand that in between these two straight lines there are two angles. One is this angle and other one is this angle. Let's say this is theta 1 and this is theta 2. Okay. So between these two lines we're going to have two angles. Okay. One is acute and other is obtuse. In one case these two angles might be equal when the angle between these two lines is 90 degrees. In that case these two angles are both right angles. In this case one angle will be acute and other angle will be obtuse. Okay. So let's discuss. I'll write the heading: angle between two straight lines. Okay. So let's suppose this is our first straight line and this is the second one. Okay. So now we know the slope of these two straight lines. Okay. So slope of the first line is m1 and slope of the second line is m2. Okay. And if I know the slopes, I will know the angle made by these two lines with the positive x-axis. Okay. So the first angle will be theta 1, the other angle will be theta 2. Now what I have to find is the angle between these two lines. The angle between these two lines will be equal to theta 2 minus theta 1. So this bigger angle minus the smaller angle will give you the angle between these two straight lines. Okay. So now I have to calculate theta, which is nothing but theta 2 minus theta 1. Okay. Now we are going to use a little bit of trigonometry over here. Okay. How? We know the value of tan theta 2, which is the slope of the second equation. Okay. If the two equations are y is equal to m1x plus c and y is equal to m2x plus c2. Any form, if the straight line is given in any form, we can easily convert the equations in this form. Okay. That I told you earlier. Now I know the value of m1 and I know the value of m2. So I know the value of tan theta 1 and I know the value of tan theta 2. So tan theta 1 and tan theta 2 are known. Okay. What I have to find is theta 2 minus theta 1. So what we're going to do is we're going to calculate the value of tan theta 2 minus theta 1. So tan theta 2 minus theta 1, as we remember from trigonometry, this formula is equal to tan theta 2 minus tan theta 1 upon 1 plus tan theta 2 multiplied by tan theta 1. This is the formula tan A minus B is equal to tan A plus tan B upon 1 minus tan A tan B. Okay. So this value is nothing but m2 and this value is nothing but m1 upon 1 plus m2 into m1. Okay. So the value of tan of the angle between these two straight lines is equal to m2 minus m1 upon 1 plus m1 m2. This is pretty much clear. So we can write this result that angle between these two straight lines is tan theta 2 is equal to m2 minus m1 upon 1 plus m1 m2. So theta 2 minus theta 1, which is nothing but theta, is equal to tan inverse m2 minus m1 upon 1 plus m1 m2. Okay. So now you have to see one thing. This value can either be negative or it can be positive. If we consider the negative value, we'll get the obtuse angle between these two lines. As I earlier told you, there will be two angles between these lines. One will be acute, other one will be obtuse. If I get positive value, the angle will be acute. If I get the negative value, the angle will be obtuse. So it's clear. So let's see some important results we derive from this formula. Okay. So we can have two cases. Two special cases. First one is the case of parallel lines. Okay. And the second case is the case of perpendicular lines. Right. So this is the case of parallel lines and the other one is perpendicular lines. So if two lines are parallel, the angle between the two lines will be equal to 0 degrees. Okay, so we can say that tan 0 is equal to m2 minus m1 upon 1 plus m1 m2, and tan 0 is nothing but 0, so this thing is equal to 0. So we can simply deduce that m2 must be equal to m1, because this will become m2 minus m1 is equal to 0, which is nothing but m2 is equal to m1. So if I have two parallel lines, m2 will be equal to m1, which means the slope of the two lines will be equal. Okay, so for parallel lines the slopes will be equal. Now we'll try to deduce this result for perpendicular lines. Okay, in the case of perpendicular lines, what we have is tan 90 is equal to m2 minus m1 upon 1 plus m1 m2. Now we know the value of tan 90 is not defined. Okay, but I know this value comes out to be 1 upon 0. Okay, we'll not see it that way. We can do is calculate the value of cot 90 degrees. Okay, this will be equal to 1 plus m1 m2 upon m2 minus m1. So why I am doing this is because this value is 1 upon 0, which is not defined. We don't operate on this scale. Okay, not defined के साथ हम operate नहीं करते. So what we do is we operate by the reciprocal of this not defined. We know that if we take the reciprocal of tan 90, this comes out to be 0, which is nothing but cot 90. So this thing will be equal to 0, and this is not defined. So we can simply say that in this case 1 plus m1 m2 is equal to 0, or we can say that m1 m2 is equal to minus 1. So in the case of parallel lines, m1 will be equal to m2, and in the case of perpendicular lines, the product of the two slopes will be equal to minus 1. Okay, so this all comes from this formula, right? So I'll write these two results over here, that in case of parallel lines, what happens is m2 is equal to m1, and in case of perpendicular lines, we have m1 m2 is equal to minus 1, which means m2 is